Let's say we're writing a library to wrap the Unix at command, which schedules jobs to be run at a later time. We already have a lower level method for executing arbitrary commands called execute. It takes a command, an optional list of flags, and an optional string to write to the command standard in. It executes the command and returns a data structure that combines an exit status object and the output of the command. We decide to drive these methods test first using RSpec. First, we write a test for the at method. It should execute the at command, passing it the given time specifier and command arguments. This is straightforward enough to test. We mock out the execute method to expect those arguments. This test is easy enough to satisfy. This is a command method. It causes some change to happen in the world around it. Next, we specify the behavior of the atQ method, which should return a list of the currently scheduled jobs. This time, we stub the execute method to return a fake command result. We take the fact that the atQ method returns part of that fake result as sufficient proof that execute was called correctly. This is even easier to make pass. We execute the atQ command and return the resulting output. This is an example of a query method. Its job is to return some information. When the at command is successful, it normally outputs a line of confirmation text showing exactly when the command is scheduled to be run, as well as the job's numeric ID. We realize that we'd like to make the scheduled job's ID available to callers of at. So we add a new example to our spec. In this example, we stub the execute method to return some faked-up command results, and verify that the at method extracts the ID and returns it. We already have a test to verify that at calls execute with the right arguments, so we won't repeat any of that here. We then modify at to extract and return the job ID using a regular expression match. But now we have a problem. Our original test for at is now failing. It's failing because the method now uses the return value of execute. And since the original test is only interested in what the at method invokes, not what it returns, it doesn't bother to set up a realistic return value for the execute mock. To make this pass, we have to update the old test, adding a return value to the should receive. Let's take a step back. We just added some extra context to our first test of at, which is completely irrelevant to that test. We did this just to keep the tests passing. From now on, we're going to have to keep doing this every time we make a new assertion about what at does. And if at ever starts using more of the return value from execute, we may have to add even more unrelated boilerplate to our mocks, just to keep the tests passing. This is the kind of thing that causes mockist tests to be accused of being brittle, and rightly so. However, before we throw away our mocks, let's take a look at what this might be telling us about our design. Earlier, I mentioned that the at method was a command method, and the atQ method was a query method. This is no longer true. The at method is now both a command and a query. This violates the principle of command-query separation, which states that keeping commands and queries strictly separated in a program makes that program simpler and more comprehensible. Another way I think about this principle is that when sent a message, you can pay it back or pay it forward, but never both. Let's change at to pay it forward. Instead of returning the job ID, we'll make it optionally yield the job ID. And now when we call at and we care about the job ID, we pass a block to it. Finally, we update the spec again. In the first example, we remove the unneeded return value from the mocked execute. Then we change the second example to test for a yielded value instead of a return. By converting a return value to a rudimentary callback, we've once again made the at method a pure command. We push values into it, and values are in turn pushed forward into the execute method and optionally into the callback block. In future episodes, we'll return regularly to the idea of command-query separation, and take closer looks at why methods in which information moves in only one direction, either forwards to other collaborators or backwards to the caller, can make a design simpler and more composable. For now, I just hope you have a better sense for when your tests are telling you that commands and queries are being mixed together. Happy hacking!
Hi there, I'm Avdi. I'm the creator of Graceful.dev. If you enjoyed the video you just watched, I want to tell you there are a lot more where that came from. Here on the YouTube channel, we regularly release new freebies from the Graceful Dev archives, so hit that subscribe button and make sure you don't miss any updates. But our YouTube channel is just a taste. Over at Graceful.dev, we've got hundreds of videos like this one. From our unparalleled coverage of the Ruby programming language, to testing and refactoring strategies, to practical skills with tools like Git and Docker, we've helped thousands of programmers grow their programming practice and level up their careers. So if you're ready for more, come check us out at graceful.dev to get access to our complete and constantly growing catalog of courses. I hope to see you there.